Dear learners, welcome to third week, lecture 1. In this lecture, I am going to derive the basic governing equations for a shell. So, in week 1, we have covered the preliminary basic equations of shells. In second week, we have derived the theory of differential equations of theory of cells and started that basic formulation of thin shell theory. So, in this third week I am going to continue the theory of cells governing equation, development of that. So, we were on that strain energy or elastic strain energy of a shell that can be written as del U, or sometimes it is known as del W of I, internal work done. For a three-dimensional case, it can be written as sigma ij del epsilon ij and dV. dV is the volume of the shell. So, we can write that volume of cell is capital A1, capital A2, d zeta, d alpha and d beta. Limits 0 to alpha or 0 to beta, or sometimes we may say that alpha goes from alpha 1 to alpha 2, beta goes from beta 1 to beta 2. It is not necessary that it should be 0 here. It may be that alpha 1 to alpha 2 and beta 1 to beta 2. Again here alpha 1 to alpha 2, beta 1 to beta 2. So, if we open this explicitly, sigma 1 1 del epsilon 1 1 plus sigma 2 2 del epsilon 2 2 plus tau 1 2 del gamma 1 2 plus tau 1 3 del gamma 1 3 plus tau 2 3 del gamma 2 3. So, it will be a very huge integral, but we will divide into sub integrals like I1, I2, I3, I4 and I5, and I will extract the terms in that integrations. Let us say for the case of calculation of I1. So, I1 is sigma 1 1 del epsilon 1 1 A1 A2 d zeta d alpha and d beta. So, del epsilon 1 1. So, del epsilon 1 1 can be, we know that epsilon 1 1 is epsilon 1 1 of 0 plus zeta times of epsilon 1 1 and 1. So, if you want to take first variation in that, so it will be del epsilon 1 1 of 0 plus zeta times del epsilon of 1 1. The expression of epsilon 1 1 0, so where these terms are related to linear and this is the non-linear terms and this terms related to curvature. Here you see that 1 by A1 is common out and epsilon 1 1 also 1 by A1 is common out. So, we will substitute the expression of del epsilon by taking del of this. So, it will be del of u1 0 comma alpha, del u2 0, del w naught, and similarly if you take the del of that, so basically it will behave like for example y is equal to u square, and if you want to take first variation of y, then it will be twice into u into del u. So, similarly it will be twice will come up, so it will get cancelled out and then del u by del alpha a1 u naught by r square multiply variation in that. Same way with the help of, if you take del psi 1 and del psi 2, zeta by 1 plus zeta by. So, here is small a1 that is kept inside, taken inside that, because we are going to use this in the definition itself. So, the dV that a1 is small a1 1 plus zeta by r1, and what is a2? a2 1 plus zeta by r2, d alpha, d beta, d zeta. If you take inside it, then bottom is 1 plus zeta by r1, that will be cancelled out. So, inside will be a1, a2 and 1 plus zeta by r2. So, sigma 1 1, 1 plus zeta by r2, take it common out, and a1 a2 if you put it inside, so a1 get cancelled out. So, finally the terms will look like this, a2, and from here they will cancelled out, and here a1 and a2 comes up. Same way I have written that linear part first and in the last the non-linear part, and here zeta times this one and a1 get cancelled out, a2 and this one. Then sigma 1 1, here you see that in the non-linear part a1 square. So, a1 will get cancelled out, but again a1 remains at the bottom. So, if we put upside, so 1 plus zeta by r2, so it will be basically, so 1 plus zeta by r2 due to this, and 1 plus zeta by r1, 1 is cancelled out and another is inverse of that, and non-linear part of this a2 by a1. Now, we can use the definition of stress resultant. You see that integration of minus h by 2 to plus h by 2. So, as per the definition of stress resultant, N11 is nothing but minus h by 2 to plus h by 2 sigma 11 1 plus zeta by r2 d zeta. M11 the moment or couple, that zeta times of sigma 11 d zeta. N12, okay, right now we are not using the definition of N12, but we are definitely using the definition of N hat 11, where N hat 11 is defined another resultant, that sigma 11 1 plus zeta by r2, that was common, but this terms comes. So, in the when we do for a nonlinear one, then we have to consider this new definition N11 hat. Sometimes in some books it may be star, tilde, delta, means we have to give a separate symbol for this definition. If we use these definitions, so they can be written like this, N11, M11, N hat 11. Now again, del u 10 comma alpha. So, there is a derivative in there. So, we want to reduce this derivative, we want to get rid from this derivative. The standard approach is that we can write N11 A2 del u naught 10 comma alpha can be written as whole derivative comma alpha minus N11 A2 comma alpha into del u naught. So, this is fine, no derivative, again no derivative, but here is derivative. So, we have to apply the same procedure, and M11 A2 del psi 1 comma alpha can be written in two terms. Same way, we will treat this as a one term, and here is a derivative comma alpha. So, it will give two terms and this will give you one term. So, from this we will get one term N11 A2 comma alpha del u naught minus sign and plus sign N11 of del u20 1 comma alpha N11 A1 A2 del w naught. Then from here minus M11 A2 comma alpha del psi 1 M11 1 comma beta del psi 2. So, they will remain on area plus non-linear part. I have done it purposefully different so that we can later on take it out. Okay, this is our linear contribution, this is our non-linear contribution. So, one contribution and this will be our second contribution. And this term, very first term will go to the boundary, that we will say along alpha is derivative. So, we can integrate along alpha. So, alpha will be limits, alpha is equal to alpha 1 to alpha 2. So, one from here, one from moment and one from nonlinear one. So, we will have 3 terms which will be the on the boundary and integration on the d beta. So, these are generally colored pink, so that we can categorize that okay, these are our boundary terms. So, similarly for I2, I3, I4 we will proceed the same procedure. Now come to I2. I2 is sigma 2 2 del epsilon 2 2 plus zeta time epsilon 2 2 of 1. So, first of all we have to write that explicit expression of epsilon 2 2 and epsilon 2 2 of 1. So, if we put the variation and put it here, here you say that 1 by A2 is common out. So, from there A2 is cancelled out and A1 will be there. So, in the definition if you using definition of N22 is sigma 2 2 1 plus zeta by R1. Definition of N21 is sigma 21 1 plus zeta by R1. M22 is sigma 22 zeta 1 plus zeta by R1. M21 is sigma 21 zeta 1 plus zeta by R1. And due to the nonlinear we have to define a new variable which is n hat 2. So, if we use these things, so it becomes n22 a1 and nonlinear terms n hat 22 a1 by a2 and couple term m22 a1. So, if we substitute there and again following the same procedure as we have done for I1 case, that we have to get rid of this derivative beta, again derivative beta, derivative beta. So, it will give you this term n22 a1 comma beta, n22 a2, n22 a1 a2 r2 comma beta, m22 linear contribution, and this will be our nonlinear contribution, and these terms will be on the boundaries, but this time it will be on the boundary of beta, beta 1 to beta 2 and integration over d alpha. Now come to the integration of I3, where I3 is tau 1 2 del gamma 1 2. So, basically gamma 1 2 expression is very big and it has two parts. One part in which 1 by a1 is common, in another part 1 by a2 is common. So, this portion is corresponding to linear part and this portion is corresponding to nonlinear part, and this is gamma 1 to 1. Here again 1 by a1 is some coefficient and 1 by a2 having some coefficients. So, from here gamma 1 to 1 by a1, let us say linear one, then tau 1 to 1 by a2 this portion, and then 1 by a1 zeta times and 1 by a2 zeta times. In the last green color one are the nonlinear terms a1 a2. So, in the first term a1 will get cancelled out, a2 will be above. In the second term a2 will cancelled out, a1 will be upper, and same way. So, we will get the two contributions. So, we know that already the definition of N12. N12 definition is sigma 1 to 1 plus zeta by R2 minus h by 2 to plus h by 2 d zeta. And definition of N21 is sigma 21 1 plus zeta by R1. So, first term will give a contribution of N12, the second term will give a contribution of N21, third term where zeta times M12, zeta times M21, and here is a new contribution N tilde. In this, if I go back in this combination A1, A2, so they will get cancelled out. So, ultimately we have a new definition of N tilde 12, where N tilde 12 is nothing but sigma 12 into d zeta. So, these are our nonlinear contribution. Again that trumps, this one, and this one having derivative along alpha and beta. So, we have to convert into a primary form and proceed further. So, from here N21 A1 derivative with respect to beta and del u1 0, then N21 del u2 0, then N12, this should be 12, so wrongly written, N12 A2 comma alpha derivative u2 0, N12 A1 comma beta del u1 0, then M21 A1 comma beta M21 from here comma alpha. So, in this way we will get all the terms which will be in the area, and the rest of the terms like whole derivative with respect to beta and whole derivative with respect to alpha go to the boundary. So, there will be some terms which will be on the boundary like beta 1 to beta 2, and there will be some terms which will be on the boundary alpha 1 to alpha 2. So, whenever we have a whole derivative with respect to beta, that will go to the beta boundary. When we have a whole derivative with respect to alpha, then it will go to a alpha boundary. Now, come to the I4 expression. So, in the I4 expression, it will be tau I3 del gamma 13. So, here tau 13 psi 1 u1 0 by r1, and if you substitute their del, so it will be del of this thing, small a1 by a1 is here. So, again we have this thing. So, if we keep inside, so bottom one a1 will get cancelled out, small a1, and so a1 a2 del psi 1 2, a1 a2 del u1 0 by r and a2 del comma. So, tau 13 1 plus zeta by r2 integration of minus h by 2 plus h by 2 is the definition of q1. So, q1 is this. So, it will be replaced by q1 and whole integral becomes an in plane integral alpha and beta, and finally terms will look like this. So, here this term having derivative with respect to alpha. So, using that concept they becomes on area and it will be on the boundary. Similarly, I5 tau 23 del gamma 23. So, if we substitute that value taking del and multiply with this a1 a2, so terms will look like this. So, definition of q2 is tau 23 1 plus zeta by r1, it should be zeta by r1 d zeta, because here is a2, so it will be get cancelled out, 1 by zeta by r1 will be there. So, again there is derivative with respect to beta, we have to get rid of that and we have to write terms I5, some terms are on the area and only single term is on the boundary. So, boundary will go to beta, beta 1 to beta 2. Now, we have to club all the terms, like terms corresponding to the kinetic energy and terms corresponding to the potential energy. In this slide, I have only put the terms kinetic energy plus the linear contribution of the strain energy. There will be some non-linear contribution and boundary terms. So, you see that it is a very big equation which will contain, and most important part is that here I have arranged that coefficient in terms of del u10, del u20. If we add all I1, I2, I3, I4 and I5 and clubbing the coefficient of del u10, del u20, del w0, del psi 1 and del psi 2. So, that will help us to frame up governing equation easily. So, these are our nonlinear terms. Like first contribution is due to I1, second contribution from I2 and third and fourth contribution from I3. And these are the boundary terms. First from I3, I4 and I5 contribution. So, these are our boundary terms. So, here pink and red one are the linear contribution, black one are and blue one are the non-linear contribution. It is a contribution due to I4 and I5. So, we have written till now that clubbing the coefficients, boundary terms separately, non-linear terms and linear terms. Now, we have to think about what left, external work done. So, we have to add, because you know that in Hamilton principle 0 to t, it is del k minus del w of I minus del w of E 0 to t dt is going to be 0. So, we have identified the terms contribution of kinetic energy and contribution due to the internal energy and put it in a simplified form arranged in a del u, del w, del psi 1, del psi naught coefficients. Now, we have to evaluate the external work done. In external force vector, we can say that, let us say a force vector q is acting on a surface. Basically, we take it is acting on a reference surface, that q, because shell is thick. So, we assume that though sometimes it is acting on the top of the shell, but external force vector is taken as at the reference surface. So, q. So, q will be component of q1 along the alpha 1 direction plus q2 along the beta direction and plus q3. Basically, our surface normal is upward, but when you apply a pressure, it will be in the opposite direction. That is why it is taken as q3 n. Basically, normal is downward direction. Now, these q1, q2, q3 may contain all possible type of body or surface loading acting on a unit area of a reference surface. It is not just a pressure that you say that only mechanical pressure may be applied. No, it may be like you are resisting, let us say that shell is resting on elastic foundation. So, stiffness of that foundation, that resisting force can be modeled as K1 U1, and that time some damping coefficients, some velocity like dynamic kind of things, that viscosity. So, damping coefficient and velocity of foundation can also be modeled. So, is Q1 can be three type. If P1 is purely mechanical pressure and this is the stiff foundation, stiffness of a foundation, resisting force basically, and this is due to the damping. So, same way we can say Q2, Q3. So, if we include, so we can say that we are going to analyze a shell resting on an elastic foundation, and some damping coefficient is also considered, or pure mechanical loading. So, in this way you can take consideration in this Q1, Q2 and Q3, and these are the components are written here. Now, we are coming to that on the edges. Let us say there will be stress resultants are acting. If we talk about the in plane resultants or that force components, only the, let us say, edge on which this beta is constant. So, over this edge, so this edge alpha is constant, and on this surface beta is, on this edge beta is constant. So, there will be force resultant. If you talk about, there will be N21 acting, then N22 acting, and shear force Q2N will be act, and they will act, total force will be A1 times of d alpha, arc length of that. Similarly, that couples may also act on the edge. So, we can say that resultant M1 couple, M2 couple on that edge where alpha is constant, on the edge where beta is constant, and this is the edge where alpha is constant, that A to d alpha, or sometimes it is basically d beta alpha 2. So, in this way we can say that on the edges there may be some force resultant and coupled resultant are acting. Now, if you say that outside forces are acting on these edges, so edges may also do contribute in the external work done. Later on you may think that a problem that in which a shell and some edge moment is applied over that edge, or that some normal resultant force is acting on the edge. So, we may consider this kind of situation. So, for that purpose, let us say some work is done, and work done due to surface forces will be Q times U L, because we are talking about on a reference surface. So, at the reference surface zeta is 0. So, A1 reduces to just A1, capital A2 reduces to just A2, d alpha and d beta, and Q naught, here we have to write del U. So, del Ws, the external work done on due to the surface forces will be Q1 del U1 0, Q2 del U2 0, Q3 del W 0. Here if you write U1, but ultimately U1 0 plus zeta times of psi 1. So, zeta is 0, so only contribution due to. Now, on the edges, that work done, that this is my basically beta s and this is alpha s. So, this will be d beta and d zeta. So, normal will be alpha sigma 1 1 into del U1. So, here bar is denoted, means the externally applied one, then tau 1 2 del U2, tau 1 3 del W, and बेसिकली आप बात करेंगे A2 एंड d बीटा 1 plus zeta by R2 d beta d zeta. So, again using the definition, here zeta is the integration and 1 plus zeta by R2. So, we can use those concept of integration, and before going to proceed further, let us define that work done by the edge 2 over this edge. So, this is d alpha and d zeta, basically A1 d alpha and d zeta surface. So, sigma 2 2 and 2 1. So, 2 1 del U1 plus 2 2 del U2 plus tau 2 3 del W, A1 zeta by R1 d alpha d zeta. If we substitute the value of U1, U2 and U3, because we know U1 is del U1 0 plus del psi 1 and so on, and using the concept of stress resultant similarly here, but it is now denoted by n bar 1 1. N bar means the applied outside So, it is slightly different, but definition wise same, just a bar is R2. So, that will contribute N11, this will contribute to N12, zeta times will give you M11 and zeta times will give you M22 and tau 13 will give you Q bar 1, A2 d beta. So, this will be the contribution of from the edge 1. Then the contribution from the edge 2 will be sigma 22 and so on, and if you use the concept of stress resultant and moments, it will come to N21, N22, M21 and M22 del side. A1 d alpha. So, now we have to club all the work done Q1 del U1 0, Q2 del U2 0 minus Q3 del W A1 A2. So, this term will contribute to the area and the other terms WE1 and WE2 will contribute to the boundary. There you see that N11, N12. So, they will be on the two boundaries where alpha is equal to alpha 1 and alpha is equal to alpha 2, and this will be beta is equal to beta 1 and beta is equal to beta 2. So, we have done that, obtained all total work done, strain energy, then kinetic energy, and we have clubbed it together. In the next lecture, I will, using the fundamental lemma of variational principle, develop the governing equation. Thank you very much.